Ladies and gentlemen of the jury and viewers watching this video, greetings. The project that I'm presenting today is to design a 32 by 32 systolic array used in the further accelerating machine learning processes and deep learning processes. The first thing that comes to our mind on hearing this is what is a systolic array? A systolic array is a sort of a matrix multiplier based on systolic architecture and is a homogeneous network of tightly coupled data processing units called cells or nodes. When a network of processing engines rhythmically produce data and flow the data through the system, that is called systolic architecture. It is used as a Go processor in combination with a host computer, and that behavior is analogous to that of the flow of blood through our own hearts, hence the name systolic. This architecture focuses on using hardware to flow data from the computer memory to different components in a precise manner before returning them back to the memory. You wonder how is that different from a conventional pipelining architecture? Well, in a conventional pipelining architecture, only the results of a few computations flow out of the system, but in systolic architecture, both input data and output data flow out in and out of the system at multiple speeds in multiple directions. Original systolic architecture was designed to be used in the VLSI implementation of some matrix multiplications, but soon it found its way into other applications as well, when it proved itself to be extremely useful and efficient in increasing computing speeds. Speaking of computing speeds, computation tasks are either memory bound or computation bound. Since systolic architecture only involves communication with the upper boundary level cells, hence the rest cells are not memory bound. Compute-bound computations are usually solved by systolic approach by dividing one main element or processing unit into smaller cells and hence increasing throughput without increasing any memory bandwidth. Now that all of us know how compute-heavy machine learning and deep learning tasks can be, thus integrating systolic arrays and systolic architecture in these processes can make a significant dent in increasing the efficiency and reducing the amount of process resources and time spent on them. That being said, it is easy to say that systolic arrays are not only limited to the machine learning side of computing, but can be used in other places as well, such as matrix algebra. And with that, I would like to end my presentation. Hope you guys liked it and found it worthy of your approval. Thank you for listening and goodbye.